Hello everybody, Matt Fraser here from Weiss Instruments. Today I'm going to be going through how to set up and configure a Eurotherm Mini-8 to get I/O data back and forth between Mini-8 over Ethernet IP and a PLC or Allen Bradley Logix Controller. So let's go ahead and get to it. I'll start walking through this. So what I have set up here is I have RS Logix 5000 on the left and iTools on the right, and I'm currently using the Allen Bradley Soft Logix PLC to act as my PLC in this configuration. So one of the first things we want to point out, and if you've had a chance, this builds on the same communication principles that we used in the Nano DAC video previously. But one of the first things to note here is that when you connect to the Mini-8 over iTools, and I'm just going to use the default configuration for this demonstration, inside the comms folder, you want to make note of this input size and this output size because we're going to need that in our Logix 5000 configuration. So I've opened up the configuration for my generic Ethernet communications inside of Logix 5000, and I'll leave this up here for a second. My particular IP address is 192.168.111.250, and you can see here that I've named the device that I'm communicating with my my generic Ethernet module as a Mini-8. The assembly instance and the output instance and the configuration numbers, these should always stay the same. But the sizes are what I'm really trying to illustrate here, and you can see that my input size inside of iTools is 40 and that my size inside of the generic Ethernet module is also set to 40. Something else to make sure when you're setting up this generic Ethernet communication configuration is to set the COM format to data int. So again, my size is 40, which matches my size inside the Mini-8. And my output size is 24, which again matches the size that I set up inside of Logix 5000. Once I have this configured, I should be able to go into the module info, and here I can see that I'm actually getting data back from the Mini-8. It's telling me that it's an Invensys Eurotherm Mini-8 device, and kind of gives me some information. So I know that the two devices are communicating with each other because I'm getting the serial number and things like that. I also have a solid green I/O light inside my Logix controller, and I don't have any kind of indication here inside of the Logix 5000 that I'm having a communications error, which will often show up here as an exclamation point. So once I have this communicating, now I have to connect which data is going to move back and forth between the devices, and in this case, what I've done here is inside my Mini-8, in my first I/O module slot, or my I/O slot, I have a thermocouple module. So I very simply just go under the I/O blocks, scroll down to the I/O mod, and the first mod 1 would be my first input inside that very first slot, which in this case again is a thermocouple module. So I just drag this block out here into my graphical wiring, and then I can actually go into the block here and I can select if it's not a J-type thermocouple or whatever type it is, to set the block up to read that information correctly. In this case, I have a jumper placed on that first input so that I can just read some ambient temperature. And then I dragged a monitor out here and connected it to the PV just so I can see it easier. And it's showing an ambient of about 97.2 degrees. Now when I move this data over, now that I have the data being read into the space, the next thing is to get this piece of information over to my PLC. And I do that inside this comms tab folder here. Now, each one of these comms tab blocks here, or folders, 1 through however many you have defined, basically is like an individual instance of a piece of information that I want to connect together to that word that's going over to the PLC. So I have to set that up and define it. So I'm going to set the first one up here, and I have already have this predefined. So there's two pieces here that you need to focus on. You need the destination and you need the source. So the source is where the information is coming from inside the Mini-8, and the destination is where I'm going to send it, or what word I'm going to send it to. So for source, this wired from column here, you can simply go in, and all I've done here is I've gone into, again, the block that I dragged out was called mod 1, so I simply go into IO mod 1, and then all I'm doing here is I'm grabbing the process variable. Let me walk back through that. IO mod 1's process variable. So once I have that defined, now the next thing I need to do is I say I want to take that piece of information and I want to get it over here to my PLC. Now this is where I guess it's a little tricky, but and I'll put these addresses in the notes for the video. But the first COM address that I can write to, or the Modbus destination address that I can write to, the first word that's available is 15360. So that range of words would be 15360 through 15399 for your input words, and your output words would be 15460 through 15483, and that directly aligns with how many of these input and output words we've defined. So in this case, I want the very first input word to read that ambient temperature value that I'm taking from IO mod 1 PV. So I'm just going to say the destination is going to be 15360, and in doing that, that places that value right here inside the PLC. Now, something of note is, if we look at this, that PV value inside the Mini-8 is actually being read as a decimal value, 97.24, and we can see that that actually gets truncated in the PLC. And the reason for that is our data type is integer. So it's going to cut off the decimal point. Now the way around that, because we only send integers back and forth, the way around that is what I've shown here, is I've just added a math block. And all I've done in this math block is I've taken this value and I've multiplied it by 100 so that I keep that, that decimal point value out there. Once I've done that, you can see it's 9721. Now I set that up in comms tab 3. So again, there's my math2.1.out. Okay, that's where it's wired from. And that's that math instruction right here. And then I said I wanted that to go to 15362, or the third placeholder respectively in sequence. And what that does is that places that value right here now inside the PLC. So now I've retained my decimal point values in the integer. Once I have this in my PLC, if I want to turn this back into a decimal point in Logix 5000, all I would do is I would take that integer value, would divide it by 100, and then the destination I would put into a real data type, and then I could reproduce that very easily back into the PLC to maintain that resolution. So that's pretty much it. That's kind of how you make the connection between the values that you're creating in your graphical wiring and get that data back and forth into the input-output words of your PLC. Now, something of note, inside this programming environment here, I've done some very simple stuff, just I/O data back and forth. However, you could easily put in PID loops or anything else that comes from inside this tool palette, and have this I/O being completed locally, and then your PLC would just sort of reside there as a supervisory type role. Because both these devices, the Nano DAC currently and the Mini-8, are both on the same network, that information could also be consumed and created from a Nano DAC that's out there working as, say, your like a graphical environment for you, or local type control environment for local PID loop control and things like that. And because they both reside on the same network, the two devices work and play well in the sandbox together. So thank you for watching. If you have any questions, always feel free to give us a call here at Weiss Instrument, and hope you enjoyed it and have a great day.